Intermediate Algebra for Statistics, Rate of Change, Part 2. Lesson Objectives: calculate the rate of change of a quantity, explain the rate of change or slope in words. We'll begin with an example. The temperature at which water boils, the boiling point, depends upon elevation. The higher you are, the lower the boiling point is. At sea level, elevation 0, water boils at 212 degrees Fahrenheit. The boiling point declines by 5.9 degrees Fahrenheit for each 1,000 meter increase in elevation. Let B be the boiling point in degrees Fahrenheit at the elevation of E 1,000 meters. Number 1, what's the independent variable? Dependent variable? Number 2, is there a linear relationship between E and B? If so, find the slope. Number 3, find the equation of the model. Number 4, perform a unit analysis of the equation. Number 5, Mount McKinley, the highest mountain in the United States, reaches 6.194 thousand meters. What is the boiling point of the water at this peak? Solution. Number 1, since boiling point depends upon the elevation, elevation E is the independent variable and boiling point B is the dependent variable. Number 2, since the boiling point depends upon elevation, we will consider the rate of change of the boiling point with respect to elevation. Because this rate of change is constant, negative 5.9 degrees Fahrenheit per 1,000 meters, the variables E and B are linearly related and the slope of the linear model is a negative 5.9. Number 3, we want the equation in y equals mx plus b form, or in this case, since we're using b and e, we want it in the form b equals the slope times e plus the y-intercept b. Now since b equals 212 when the elevation or e is 0, the y-intercept or the capital B intercept is 212. We also know that the slope is negative 5.9, so our equation is b equals negative 5.9 times e plus 212. Number 4, here's the unit analysis of the equation. The units for B is degrees Fahrenheit and the units for E is 1,000 meters. So we have B, which is degrees Fahrenheit. This is our slope, negative 5.9, which is degrees Fahrenheit per 1,000 meters. Our independent variable is 1,000 meters, and 212. The y-intercept is degrees Fahrenheit. Now we're going to use the fact that this 1,000 meters and this 1,000 meters will cancel, and we have degrees Fahrenheit plus degrees Fahrenheit equals B, which is degrees Fahrenheit. So the units of the expressions on both sides of the equations are degrees Fahrenheit, which suggests that our model is correct. Number 5, to find the boiling point, we substitute the input 6.194 for E into the equation. So we take negative 5.9, multiply it by our elevation, which is 6.194, and then we add 212. And we get approximately 175.46. So when the elevation is this high, the boiling point of water is approximately 175.46 degrees Fahrenheit. Let's do another example. Yogurt sales. Yogurt sales in the United States are shown in the table for various years. Let S be the yogurt sales measured in billions of dollars in the year that is T years since 2000. A model of this situation is s equals 0.17t plus 2.15. Use a graphing calculator to draw a scattergram and the model in the same viewing window. Check whether the line comes close to the data points. Number 2, what is the slope of the model? What does it mean in this situation? Number 3, find the rates of change in sales for one of the years to the next. Compare the rates of change with the result in part 2. Number 4, what's the s-intercept? What does it mean in this situation? Number 5, predict the sales in 2015. So if you recall, to plot a scattergram, we need to go to Stat, go to Edit, hit Enter. If you have any data in List 1 or List 2, you can clear them out using your up arrow key, hitting Clear, and Enter. Same way with List 1, Clear, and Enter. So our independent variable is years since 2000. So the first one will be a 1. The next line will be 2. Until we get to 5. The dependent variable, 2.3, when t is 1, 2.5, 2.7, 2.8, and 3. Now we go to second y equals, which is stat plot. We want to turn it on. So we hit Enter. For type, it's the first one. Our X list and Y list, list 1, list 2, that looks good. Now if you recall, before we hit graph, we want to hit zoom, and we want a zoom stat. Number 9. So this is the data. The problem also asked us to graph the model to make sure it fit. So we hit our y equals. We type the equation in, 0.17, our independent variable, plus 2.15. We hit graph, and we can see that this linear model is fitting the data very good. So using the graphing calculator, we can see that the line comes close to the data points, so the model is a reasonable one. Number 2, the slope is 0.17 because s equals 0.17t plus 2.15 is in the form of y equals mx plus b, and m is 0.17. According to the model, sales are increasing by $0.17 billion per year. Number 3, the rates of the sales are shown here. All of the rates are fairly close to $0.17 billion per year. So it's close to being linear. If you see here, if you can compute the slope for these two order pairs, you get 0.2. These two order pairs, you get 0.2. These two order pairs, you get 0.1. And the last pair, you get 0.2. So these are roughly the same as 0.17. And that's why our linear model did a pretty good job of estimating this data. Number 4, the s-intercept is 2.15, and this is because it is the constant b in our y equals mx plus b form. What does this mean in the terms of this situation? According to the model, yogurt sales were 2.15 billion in the year 2000. Lastly, number 5, we want to predict the sales for the year 2015, which means T, the number of years after 2000, is 15. So we substitute 15 in for T and solve for S. So this is 0.17 times 15 plus 2.15, and we get 4.7. This means, according to the model, yogurt sales will be 4.7 billion in the year 2015. Thanks for watching.